I am avatar organized by Professor Farooq Alami and Kirti Reddy. These slides show you how to perform likelihood ratio calculations in All of Us for the Missing Value project. This slide shows on how to create new notebook. Choose an app in your workspace. Select Jupyter and click Next. We name it to likelihood_ratio_work. Select Python as the programming language and then create notebook. Import libraries and read files. Created earlier one is target file, which has all the targets, 527, and then medical events file. This slide shows how to list out the columns and retain unique values in a medical events data frame. This slide establishes a connection to an SQLite database and then writes two data frames, targets_df and medical_events_df, into the database as tables. This slide shows on how to add new underscore code to both the tables and then populating new underscore code by concatenating standard underscore vocabulary and standard underscore concept underscore code. Import all the necessary libraries. This slide explains how to generate work from the work file by first loading the work file and filtering the data. It selects only the rows where the task is not yet completed, ensuring that only unfinished work is included. Additionally, for testing purposes, a limit can be set to control the number of work items processed. This slide demonstrates the use of a context manager to efficiently manage database connections and also establishes a connection using SQLite 3 and ensures that the connection is automatically closed after use. This approach helps prevent connection leaks and improves database performance. This slide explains how to filter relevant data for analysis. The first function extracts specific target records based on a given condition and stores them in a temporary table for further processing. The second function removes any medical events that match the filtered target records. This slide explains how to label medical events based on their relevance to the target group. First, a new column is added to store the target label, initially set to 0 for all records. Then, the column is updated to 1 for records where the person has been identified. This step ensures that medical events are correctly marked based on whether they are associated with the target population. This slide explains how to calculate key statistics for evaluating the relationship between medical events and the target group. IT counts how often each medical code appears in both the target and non-target groups, calculates the total number of unique individuals in each group, and determines the overall occurrence. This slide explains how to calculate and store the likelihood ratio for each medical code. This step helps quantify how strongly each medical event is associated with the target condition, aiding in further analyzing the likelihood ratio values. This slide covers two key steps in storing likelihood ratio results. First, a new column ranks the likelihood ratios. Values greater than or equal to 1.0 retain their ratio, while those less than 1.0 are inverted. Next, a permanent table is created from the temporary LR_ results, ensuring that it is saved for future use. In this slide, first, a temporary table filters the LR results table to select the top features based on LR ranking and a minimum count. This focuses on the most significant features for analysis. Second, a temporary cohort table is created to track the personality ID and target status for medical events tabulating in subsequent analysis. This slide explains a function that sanitizes column names for use in SQL queries. The function first replaces any invalid characters in the column name with underscores. If the name fits within the maximum allowed length, it returns the sanitized name. If the name exceeds the limit, the function truncates it and appends a random suffix for uniqueness, ensuring the name remains within the length constraint. This process prevents errors related to invalid or overly long column names in the database. This slide explains the process of creating a temporary table for selected events. It first filters data from the table by selecting distinct values. The selection is based on matching new underscore code values that are also present in the LR_ results table. This ensures that only the relevant medical events linked to significant features are included in the new table, which is crucial for further analysis. This slide describes creating a table with dummy variables. It converts each unique concept code into a separate column with values 1 or 0, representing the presence or absence of each concept. The original concept underscore code and unnecessary other columns are then dropped, preparing the data for analysis. This slide outlines 2 steps for finalizing the analysis data. The analysis underscore dummies table is grouped by person underscore ID, selecting the maximum value for each concept. A permanent table is created from the temporary table, storing the results based on a current target. This slide shows a function write underscore alert message that logs a timestamped alert message to a log file. This function processes the likelihood ratio for a target by filtering and saving target-specific rows in filtered underscore targets, checking if any target data exists. If not, it alerts and exits. Filtering new underscore medical underscore events and saving relevant data in filtered underscore medical underscore events. Adding a target column to filtered underscore medical underscore events based on filtered underscore targets. This function further processes the likelihood ratio analysis by creating and calculating likelihood ratios in LR underscore results, ranking and saving the results in a persistent table for later analysis, filtering the top features and creating the cohort table with unique persons, selecting relevant medical event data and preparing it for analysis, converting concept underscore code to dummy variables and grouping data by person underscore ID, saving the final analysis in a persistent table for the target. This slide shows code on how to start a connection to the SQLite database Mental Health DB. This code is used to process likelihood ratios for rows in a data frame, workfile underscore DF, with progress tracking using TQDM. Save the updated file into a CSV and check your results.